Hi everyone, welcome back. In part 2 of our Python crash course, we're going to take a look at the different data structures available in Python, and then we'll have a look at some of our different operators. Let's move over into Jupyter Notebook and get started. Let's start by introducing data structures. In Python, data structures serve as an efficient way to store and organize data, and although they share some similarities with variables, they serve two distinct purposes. Variables are utilized for storing and manipulating individual values or objects in memory, but are not data structures themselves. On the other hand, data structures are a more complex organizational format for storing and accessing multiple objects. There's many different data structures available, including lists, dictionaries, sets, and tuples. And we'll start by looking at lists. Lists are a sequence of elements that are used to store multiple different items inside of a single variable. Lists are created with square brackets and the values inside of them are separated with commas. And to create a list of integers, we can start with our square brackets, and then inside of here, we'll add in our numbers with a comma separating each number. And then if we run our type function on this, it will return the type of list. Lists can also be used to store strings too, as we can see here. It's also possible to assign a list to a variable. So I'll go ahead here and create a variable called countries, and then I'll assign a list containing 5 different countries. So the UK, US, China, Norway, and Japan to this list. If we print this list out, we'll get our 5 different countries. And we can index our lists using the same square bracket notation as we used before. So if we go ahead here and index our list at position 0, you'll see that it returns the entire element at index position 0, which is the United Kingdom. And if we index at position -2, we get Norway. An important point about lists is that they are a mutable data structure. And this means that even after they've been created, we can alter the elements inside of them. For instance, we could replace Norway at position 3 or -2 if we use negative indexing and set it to Canada. To do this, we'll index our list at this position, and then at the end, we can simply assign our new country, which is Canada. If you want to add elements to the end of your list, you can use the append method. So in the same way that we have string methods that we looked at before, we also have different list methods that we can use to manipulate our lists. So we'll type in the name of our list, append, and then in parentheses, we need to pass in what we want to add to our list. So if you wanted to add in Italy, we can just type that in here. And then if you run the cell and then look at our list, you can see that we have Italy at the end of the list. We can also use the insert method to insert an element into a list at a position of our choosing. So let's add Spain to the start of our list. We'll call the insert method on our list, and then this time we'll have to provide 2 arguments. The first being the index position that we want to insert it at, which we'll do at the start, which is index 0, and then next the value that we want to insert, which will be Spain. And then if we check the contents of our list, we'll see that Spain has been added to the start of the list. As well as adding elements from our list, we're also able to remove them too, with either the remove or pop methods. Remove lets us specify which value we want to remove from our list, whereas pop just removes the last element from the end of our list. Let's start by using the remove method to remove Spain from our list. If we check, we'll see that Spain is no longer present. And note here that Italy is now the last item in our list. When we pop an item from our list, as well as removing the item, it also returns it as well. So if we now call the pop method on our list, we'll see that it returns Italy, and it's also gone from the list as well. Next, we'll have a look at how to sort lists. For this example, let's create a new list containing some different numbers. So I'll call mine number list, and then I'll add in a few different numbers. So I'll go for 10, 8, 24, 17, 3, 6, 2, and 9. And let's use the sort method to sort this list in ascending order. So we'll have the name of our list, and then sort, and then if we view our list again, we'll get the same numbers, but this time sorted in ascending order. If we passed reversed argument into our sort method and set this to be equal to true, then our list would be sorted in descending order, but I'm not going to run this. Something important to know about lists is how their memory management works behind the scenes. Instead of going into boring technical detail, I'll show you a quick example. Let's create a new list, which will just be a copy of our first number list, and I'll call this list number list 2, and this will just be equal to our first number list. So currently, number list 2 is the same as our original number list. Let's now pop the last item from our original number list, and this is 24. As we created our second number list before we popped this item, it makes sense to expect that 24 would still be present in our second list. But if we take a look, we can see that it's gone. And this is because when we copy a list like we just did, instead of creating a new object in memory, the new list just point to the same memory reference as our first list. So both the variables are referencing the same point in memory. So any changes made to one will be reflected in the other. To make an explicit copy of our lists, we'll need to pass in the copy method, which will force Python to create a new object in memory. So we can just say, for instance here, number 2 list copy, and this time we'll make it equal to our number list, but we'll explicitly copy it by passing in the copy method. And then the last thing we'll look at with our lists is the fact that we can actually nest lists inside of each other. So I'll create a new list here, and then I'll start it by entering 1 and 2. And then within our first list, we can actually create another list. So I'll open a new set of square brackets, and then put in 3, a comma, and 4, and then now I'll close this list here. And then finally, we can add in another list. So I'll put in a final list here containing hello and then world, 2 separate items. If we have a look at our nested list, we have our first 2 numbers here at index 0 and index 1, but then at index 2 we actually have a whole list. So index 2 would actually return both 3 and 4, and that's because index 2 is actually this whole other list here. And then index 3, we have another list containing both hello and world. And let's say that we wanted to grab just hello from our final list here. Instead of just specifying an index of 3, we can actually provide 2 indexes. Inside of our hello world list, hello is at index 0 and world is at index 1. So all we have to do is add on another set of square brackets to our index and provide our second index of 0. If we run the cell, we'll just get the output of hello. Okay, perfect. So that's everything for our lists. We'll now move on to looking at dictionaries. And dictionaries are a data structure that can be used to store data in key value pairs. To create a dictionary in Python, we need to use curly brackets. Let's create an example dictionary on some employee data. So as mentioned, this time we'll need to use a set of curly braces instead of these square brackets. And then to start, we'll need to provide our key, which I'll call name. Then we can enter a colon, and then we'll provide the value for this key, which I'll set as Alan. So we have a key called name, and then a value for this key, which is Alan, and then a colon separating the key value pair. We can add more key value pairs into our dictionary, so we'll go ahead and do another few examples here. Our second key will be the age with the associated value of 34, and finally we'll have our job title. We can view all of the keys in a dictionary by calling the keys method on our dictionary, and then we'll get our 3 keys returned as we can see here. And then we also have the values method, which will return all of the values in our dictionary too. If we want to index our dictionary, instead of using the index position like we have done before, we'll instead have to provide the key. For example, if we try and index our dictionary at position 0, we'll get a key error of 0, and that's because this key doesn't exist. Instead, we'll have to enter in the name of our key, which for the first one here is just name, and then this will return the value associated with that key. Like lists, dictionaries are also mutable. Let's now add in a key value pair to our dictionary for this worker's office. Inside the square bracket notation for this dictionary, we'll enter in office. Currently, this key doesn't exist within our dictionary. If we say that this key is then equal to New York, and then check our dictionary again, we'll see that at the end of our dictionary, we now have the additional key value pair, so the office key with the associated value of New York. And it's also possible to update the values inside of a dictionary using the update method. Let's update the office for this worker to be California as opposed to New York. We can call the update method, and then inside of here, we'll enter a new key value pair of office and California. The pop method that we looked at for our lists also works on dictionaries too. If we provide the pop method with our key name, it'll remove and return the associated value of that key, as we can see here. Okay, and great job. We're making some really great progress here. We've already covered lists and dictionaries, but there's another two main data structures to have a look at, and these are tuples and sets. Tuples are similar to lists, like we've looked at already, but instead of using square brackets, like we did to create our list, we instead use parentheses. So I'll create a tuple here, called tuple1, and then inside of our parentheses, I'll pass in a few different values. The main difference between tuples and lists is that tuples are immutable. So remember when we changed an element inside of our country list to be a different country. If you try and do the same on our tuple, so reassign an element inside of our tuple, we'll receive an error telling us that the tuple object does not support item assignment, which confirms that tuples are immutable. And now we'll have a look at our final data structure, which is the set. And sets are an unordered collection of unique elements, and this means that they can't contain any duplicate values. To create a set, we use the same curly braces that we used for our dictionaries, but this time we just won't provide a colon for the key value pair. Instead, all we have to do is enter our values. Let's create a set here with 4 separate elements of A, B, C, and D. And let's now create a new set, but this time with a few duplicate elements. So we still have A, B, C, and D, but this time we have a few duplicates in here too. If we run this cell to output its contents, we'll see that we actually get the same output as before. And this is because, as mentioned, a set can only contain unique elements. Any duplicate elements or values are discarded from the final output. And the other thing I mentioned is that sets are unordered. So if we try and index our set, we'll get an error telling us that the object is not subscriptable. And this is because there is no index order here, so there are no positions to index from. So these are all of our main 4 different data structures. And just to recap, we had lists, dictionaries, tuples, and sets. We'll be using these more throughout the rest of the course, so we've got plenty more time to practice. Let's now move on to looking at the different operators that we have in Python. Operators are special symbols or characters that perform some kind of computation on our values, variables, or data. To start with, we have our comparison operators, and these are also known as relational operators. These compare 2 values and will then return a binary true or false value based on the results of the comparison. And here we can see a list of all the different comparison operators that are available inside of Python. There's 6 in total, including equal to, not equal, greater than, less than, greater than or equal to, and finally less than or equal to. And then off to the right here, we have an example of 5 and 10 with the relevant output of each operator. And now that we know what our comparison operators are, let's have a look at a few examples in Python. So here we could say, is 5 equal to 10? And note here, I'm using 2 equal signs. A single equal sign, as we've used before, is the assignment operator. And for the comparison equal to operator, we'll need to use a double equal sign. If we try and use 1, we'll get an error, as we can see here. If we run this cell, it'll return a Boolean value. Here, 5 is not equal to 10, so it returns false. But if we change this to be not equal to, and from the slide before, we know that this is an exclamation mark followed by an equal sign, then we would get true, because 5 is not equal to 10. So this value is true. After this, we had our greater than and less than operators. So here, is 5 greater than 10? And this is false. And of course, is 5 less than 10? Then the output of this is true. And then finally, we have our greater than or equal to operators. For instance here, 10 is not greater than 10, but it is greater than or equal to 10. Let's build on these operators, and now we'll introduce logical operators. Logical operators can be used to perform logical operations on Boolean values. There's three main different types of logical operators inside of Python, and these are the AND, OR, and NOT operators. The AND operator will return true only if both operands are true. Otherwise, it'll return false. Next, we have the OR operator, and this will return true as long as at least one of the operands is true. And finally, we have NOT, and this will just invert the true or false value that it's provided with. And let's now put these into practice back inside of our notebook. For our first condition, we'll have is 5 less than 10. Then we'll provide the AND keyword, and now we can enter another comparison operator. So I'll put is 50 less than 40. If we run this, we get the value of false, because the second part of our AND statement here is false, as 50 is not less than 40. So basically, this is saying true and false, but because AND requires both operands to be true, then this returns false. If we change our AND to be an OR, then this will return true, as the first operand is true. To make this a little bit easier to read, we could also wrap each of our comparisons of our operands in parentheses, which is recommended for easier reading. And then finally, let's take our example of is 50 less than 40, which is currently false, and wrap this inside of the NOT operator. And then if we look at the output, we'll see that this becomes true. The very last type of operator and topic for this lecture is the membership operator type, and this is a very quick and easy one. There are two types of membership operator, in and not in. The in operator is used to check whether a value is present inside of a sequence. It'll return true if the value is found, or false if the value is not found. And of course, not in will check the opposite, so if the value is not present. Let's start here by creating two different variables, A and B, and then we'll assign the values of 20 and 35 to these respectively. We'll then create a new list containing some different numbers, so 5, 10, 15, 20, 30, and 40. If we now say A in list, this will return true, as A is equal to 20, and 20 is in our list. If we try this with B, which is 35, this will return false, as 35 is not in our list. And of course, with the not in operator, the values of these would be flipped, as it's checking to see if the values are not present. Just to quickly show you, these operators also work with strings. So if we create a new variable called word, and then assign a string to it, I'll just enter data. We could also ask, is the letter T in our word variable, which it is, so of course this here returns true. Okay, this is turning into quite a long lecture, so we'll leave this one here for now. We'll go and take a well-deserved break, and then in the next one, we'll take a look at some of Python's more advanced features, such as if, else, and else-if statements, different kinds of loops, and also a quick introduction to functions inside of Python. I hope you found this lecture valuable. Let's go and have a break, and I'll see you in the next lecture.